All right, guys, today's lesson is on a topic called electronegativity. You guys remember we've been introducing periodic trends, atomic radius, how large atoms are, how that is arranged in the periodic table, along with ionization energy, and then electronegativity. So we'll review here quickly some of the things we looked over before he says, uh-oh, crashers, party crashers, crash test dummies. Police department Halloween party, best costume, here I come. They're all dressed as dummies. All right, so you guys, this was from the last lesson, so you don't need to take notes on this if you had already done so previous. Remember, from left to right, atoms tend to get smaller. And you guys remember why that is? If you look, as you go left to right, the atomic number gets bigger, greater positive charge in the nucleus, pulling those negative electrons in, therefore the atoms get smaller. When you go from top to bottom, the atoms tend to get bigger. And you guys remember why that is? Because each time you go down a row or a period in the periodic table, that corresponds to a shell of electrons. So just imagine these underlying shells of electrons which shield out, right, the positive nucleus's attraction for the outer electron. Therefore, less attraction, therefore the electrons are freer to move further out from the nucleus. That's called the screening effect. Okay, so this was all reviewed from the last time. Then the ionization energy, remember, is the energy needed to remove the outermost electron from an atom. And we then made some predictions. As you go from left to right in a period, the ionization energy increases, meaning it's harder and harder to pull the outer electron off. And why would that be? If we just look, one of the reasons is, once again, because as you go left to right, you have a greater positive nuclear charge holding more strongly onto those electrons, therefore requiring more energy to remove it. And then you remember also, the atoms are getting smaller, so the outer electron would be closer to the nucleus and therefore more tightly held. And then when you went from top to bottom, the ionization energy decreased. Remember, the reason for that was, once again, the screening effect. More and more shells of electrons underneath, and therefore screens out. Therefore, as you go down, the electron is less tightly held, therefore it requires less energy to remove. And then lastly, because the atoms get bigger, the electrons further from the nucleus, also contributing to the fact that it's not tightly held. Okay, so that was all review. Says they're sitting on a roof. Sometimes I worry that everything in my life has been a mistake. I don't know if you guys can see it. M-I-S-S-T-A-K-E is in his word bubble. And the dog says, dude, mistake only has one S. Okay. Electronegativity, guys, this is the new stuff. We can also call it electron affinity. And you guys should know, if I said I had an affinity for chocolate, what does that mean? It means I like chocolate. So what's electronegativity or electron affinity? It's an attraction for electrons, a desire for electrons. So that's what that term means, a measure of the tendency of neutral atoms to attract electrons. Okay, so you guys were going to make predictions. So this is kind of representing that. Think about it, a neutral atom, and it can have an attraction for an electron. Once again, what's going to attract an electron to an atom? Is it going to be the positive nucleus? So if a neutral atom attracts an electron, doesn't the atom itself become negative? Because now it'll have more electrons than protons, right? And in so doing, electrons actually released. Energy is released. See how that's different than ionization? It takes energy to remove an electron. Energy is given off when an atom attracts an electron. So we want to make a prediction from left to right. I'm hoping at this point you pause, you look at a periodic table and think, okay, is it going to increase or decrease? Hopefully you guys came to the right conclusion. It will increase. Notice it says until the noble gases. And what might be a reason for that? So let's just look at a periodic table. So we can maybe come up with, well, first of all, just so we're clear what we're talking about. So what we're saying here is when we go left to right, the electronegativity is going to be increased. In fact, I could have just looked at this, right? I'm just kind of using period 2. Notice I said until the noble gases, because you think about it. You remember what's significant about the noble gases? Their outer shell of electrons is already full. Notice helium has 1 filled shell of electrons. Neon has 2 filled shells of electrons. Argon, 3 filled shells. So those are already happy, fat, content, stable. They have very little to no attraction for extra electrons, right? And that explains why they're pretty non-reactive. They don't have to gain or lose electrons in order to fill their outer shell. So anyways, what might be a reason? In fact, you know what? We probably didn't even really need the periodic table for that. So the question is, where would a neutral atom get an extra electron from anyways? Just imagine another electron, right? Right, we're talking about the attraction for a neutral atom. Well, wouldn't it get it from other atoms, right? So we're saying fluorine has a greater attraction for electrons than lithium does. Why might that be? I think you guys are seeing a lot of it's the same rationale. Increase in nuclear charge. Once again, guys, look, more protons, that's going to have a greater pull for any extra electrons, and therefore that would explain why electronegativity increases. And also, once again, what do you guys notice? It's the same reasoning that we've used before. Don't the atoms get smaller? So in this case, wouldn't an electron from another atom be able to come to in closer proximity, closer toward the nucleus of this atom, and therefore have a stronger attraction? So those are the two reasons. You guys, we're going to finish with top to bottom. So now you guys just look top to bottom. We don't really have to look at a periodic table, just kind of look at this. Okay, hopefully you guys already have this drawing written down. So the question is, what do you guys think might have a stronger attraction for an extra electron, right? When we talk about an extra electron, like would be attracted and then occupy an orbital in the outer shell. So does it increase or decrease? Hopefully you guys concluded it decreases. What we're saying is, as you go down, there's less and less of an attraction for extra electrons. Now, why might that be? Hopefully you guys realize, once again, it's some of the same reasonings. An increase in the screening effect. You guys remember, look, there's more and more shells. You know, if it helps you guys to see even better, we'll just put some more shells in here, right? There's just more and more shells of electrons. These inner shells are all filled with core electrons, right? Once again, that shields it, and therefore there's going to be less of an attraction for an electron from another atom, and its attraction for the positive nucleus of this atom. And then another reason is, you guys notice once again what's happening to the atoms, they're getting bigger. And once again, so there would be less of this electron can't come in close proximity to that nucleus, and therefore there's not a strong attraction for it. Okay. You know what? We're not going to do the quiz. What I do want to show you here is, so based on that, guys, I'm hoping you guys could determine what do you guys think. So here's the question before I put it up. What do you think is probably the most electronegative atom then? You guys look at the trends, right? It increases this way and it decreases this way. So looking at a periodic table, what do you think would be the most electronegative atom? I'm hoping based on what we just said, you're like, oh, doesn't that have to be somewhere in the upper right? So what do you guys think would be the most electronegative atom? Hopefully you guys guessed correctly. That would be, if we look, so these are just all showing us electronegativity values, and I don't know if you guys can see really up close, but you guys should notice, like, they all have different values, like carbon's 2.5, nitrogen 3.0, just like we expected, right? Electronegativity increases, you go up. And then if it decreases, you go down. Wouldn't it be in the top right? The most electronegative atom is fluorine. And you look, what's closely second, the next most electronegative atom is actually oxygen. These have a very strong attraction for extra electrons. Okay, so now what I'm hoping you guys would do, just to summarize, let's summarize the last 2 days. You guys just kind of draw a little periodic table on your paper, your video notes. Okay, so we already know here, up here in the upper right, that has the highest electronegativity. I'm just going to put electro. So if you want to know the more electronegative atoms, isn't that going to be in the upper right? The question is, where do you think you're going to find the ones with the highest ionization energy? So now we're kind of going back to the previous lesson. Remember, that's the ones that are going to hold on to their electrons the tightest. When you guys agree, wouldn't that also be, I'm going to put IE, short for ionization energy. That's also going to be in the upper right for the exact same reasons. Not only do they hold on to their existing electrons more tightly, they're more inclined to attract other electrons from other atoms. And then, last question I have, where do you think we're going to find the biggest atoms, the ones that have the largest radius, the most biggest, daddiest atoms of them all? Where do you guys think those are going to be? Where in the periodic table? I should just show a regular periodic table. You guys got to go back to our trends. You know, and you don't even need the periodic table. Just look here. Where in the periodic table would you find the largest atoms? Hopefully you guys guessed it right. It's in the lower left. I'm going to put up arrow. That means the largest atomic radii. I'm sorry, radii. That just means, right, large. So like, for example, you would probably predict maybe francium would be the largest atom in terms of atomic radius. All right, guys, that's it for electronegativity. Tune in next time. We'll see you then. Bye.